Hi everyone, my name is Asyaba,
My name is Reese Nordstrom.
I'm Parth.
And I'm Luke.
and we're excited to present our analysis for the Virginia Datathon. So for this, we decided to focus on using crash data to uncover the most dangerous zones and conditions across the state and explore how data and machine learning can help save lives on the road. We started with a simple and but urgent question, which is which areas and conditions contribute most to fatal crashes in Virginia? With over 1.2 million crashes in our data set from 2016 to 2025, we saw an opportunity to look into the pattern behind where and why these severe crashes happen. To do this, we use crash datasets directly from Virginia's Department of Transportation's Open Data Portal. These datasets included a wide range of variables, which gave us a rich foundation to work with, both for our analysis and for the modeling later on. So the first step was exploration. Using data, we visualized the data using Tableau, we visualize the data to uncover trends, patterns, and potential predictors.
So our first step was calculating zones, basically a 10 by 10 mile grid laid across Virginia, just to put crashes in to see where hotspots of high fatality, high severe injury crashes were happening. We found from this that interstates, especially around cities like Richmond, Virginia Beach, Northern Virginia, Roanoke, had very high rates, and even some isolated rural zones were there as well, suggesting things could be done in those areas to help mitigate.
Our next step was to incorporate the pedestrian population into our analysis, and we saw that those clusters appeared also in urban areas like Virginia Beach, Richmond, and Washington, D.C., and they created two or three-way intersections where the speed limit of those roads is less than 35 miles per hour.
So, quick preview of our dashboard to help visualize. We started off with interstates because of the just way higher level of fatalities. And this map up here, you can click crashes by the route, and it'll show you the zones, those 10 by 10 mile zones uh, along the route that had high fatality rates. So let's take this one in the middle. We can see how many fatalities this zone in the middle of 95 had, and how many incidents of large trucks and motorcycles and alcohol involved. You can really break it down with these.
So for the non-interstates, we focused on the top 10 worst roads where the speed limit was less than 35 miles per hour. And if we zoom into Richmond, we can see one northbound, and you can see just how many pedestrian-related incidents there are on that road and on other roads where the speed limit is less than 35 miles per hour.
Okay, to our model.
Awesome. Now, moving on to our model, we were successful in making a deep learning sequential neural network for our dataset to predict the severity of crashes. To give a brief overview, our input variables were one hot coded physical parameters, and our output variables was one hot coded crash severities. Uh, the limitations we faced were our dataset was imbalanced, wherein one crash was severely more than the other crashes. Contextual features were missing, for example, time of the day and traffic volume. And we also had high variance leading to an overfit in our data. Results were consistently giving us an accuracy between 60 and 70%. Further, we wanted to look at why our deep learning model is really important. Accident severity prediction can save lives, and it can help in establishing a really strong and well allocated emergency response infrastructure across Virginia. We also believe that our algorithm can be incorporated with car alert systems and navigation apps to help drivers alert on risky roads and sections.
The final recommendations is that is our neural network utility, just incorporating random simulation with predicted probabilities and using external variables to improve our model accuracy. Also, wish we had more time to develop the dashboard design and just the road ahead. Data alone isn't enough, but data used wisely can save lives. Let's harness AI to make every intersection smarter and every mile safer. Thank you.
Thank you.